So just to quickly recap, what is a double displacement reaction? Think about a double displacement reaction as being you've got two compounds, two ionic compounds. One is Reese's Pieces as your cation, bonded to O. Henry as your anion. The other compound is Reese's Peanut Butter Cup, bonded to a Hershey's bar as your anion. So the Reese's are the cations, and the chocolate bars are the anions. What happens is those cations stay in the same spot. So Reese's Pieces and Reese's Peanut Butter Cup stay just where they are, but the O. Henry bar swaps places with the Hershey's bar. And so now you have a Reese's Pieces bonded to the new anion, Hershey's, and the Reese's Peanut Butter Cup now bonded to the O. Henry.
So how do you know if a double displacement reaction will even happen? There's three ways a double displacement reaction you know will go forward and actually happen. One is if one of your products is a precipitate, or if one of your products is a gas, or if one of your products is water, which is a neutralization reaction. In this video, we're going to look at double displacement when one of your products is a gas. So this is an interesting one. In double displacement reactions, you just swap the anions, keep the cations in the same place. But here's the difference with this type of double displacement. One of your products that you form will actually be unstable and it'll immediately decompose into a gas. So it won't stay itself, it'll actually break apart into water and a gas. So in this type of double displacement reaction, you actually get two reactions happening really fast, one after the other. The first is you do a regular double displacement, but you form an unstable compound, and there's only two of them that we need to memorize, carbonic acid and ammonium hydroxide. If you spot either of those as your products, those guys are unstable, and right away they will break down into a gas and water. So if we see a product being carbonic acid or ammonium hydroxide, this is going to be a double displacement that will go forward and form a gas, even though carbonic acid and ammonium hydroxide are both actually soluble. They'd be aqueous compounds, so they don't form a precipitate. The thing they form is a gas. So here they are, the two to watch out for. So carbonic acid is the first one. If you see carbonic acid as one of your products, it will not stay carbonic acid. This guy will right away break down into water and carbon dioxide gas. Just to remind you of how do we know carbonic acid was H2CO3? It comes from carbonate. So carbonate is one of your polyatomic ions. Carbonate. When you have a polyatomic ion with an ending 8 and you change it to ic acid, that means that you've brought in some hydrogens to bond to that polyatomic ion. So carbonate is CO3 with a 2- charge. And because it has a -2 charge and hydrogen ions have a +1 charge, just +1 here, you're going to need two hydrogens to make that carbonate happy. So it'll be H2CO3 when you make carbonic acid. So carbonic acid, this guy right here, watch out for him. If you see a product that is carbonic acid, it will not stay carbonic acid. It will break down into water and carbon dioxide gas, and that will mean that double displacement will go forwards with those as the product, that gas, carbon dioxide gas as the product. The other one to watch out for is ammonium hydroxide. So if you see ammonium hydroxide as a product, that is not stable and it will immediately break down into water and ammonia gas. Just something to watch out for here. Ammonium is the polyatomic ion. Notice that it's NH4 and it carries a +1 charge, which is why it could even bond to that hydroxide, right, and make ammonium hydroxide. Ammonia is a gas. It's not a polyatomic ion. That's not an ion at all. That's actually a molecule that's totally neutral. That's NH3, a nitrogen and 3 hydrogens. So it's ammonia, not ammonium. I'll just write it down for you here. Ammonia, which is a gas. So if you see ammonium hydroxide as a product, immediately break it down into water and ammonia, and that will be a double displacement that goes forward. Let's try a fun example. So when you were a kid, you probably made volcanoes by mixing baking soda and vinegar. It's a super fun experiment. And what makes it fun is, of course, that it bubbles up really fast, right? And that's a gas being produced. The gas that's being produced is carbon dioxide gas in this reaction. So what are these things? So your reactants here are vinegar. Well, vinegar is actually just acetic acid, and it's mixed with a lot of water. So there's some acetic acid in solution with a lot of water in your vinegar. And then baking soda, there's two names for it, sodium hydrogen carbonate or sodium bicarbonate. Hydrogen carbonate and bicarbonate are the same thing. They're just two different names for HCO3, which is a polyatomic ion. So this is the word equation, but this one's actually easier to see in the actual chemical formulas, I think. So acetic acid is an acetate, which is C2H3O2. That's one of your polyatomic ions. Bonded to an H, right? When we bring an H into acetate, it becomes ic acid, acetic acid. Sodium bicarbonate or sodium hydrogen carbonate, same thing, is a sodium bonded to a hydrogen carbonate polyatomic ion. When we do the double displacement, we keep the cations in the same place. So keep that H and keep the sodium just where they were. But what we're going to do is swap the anion. So we're going to swap that acetate ion with the hydrogen carbonate or bicarbonate ion. Those guys will swap. So when we bring the bicarbonate over here, it has an H actually with it, right? That goes with it. That's actually just going to join the other H here, so I'm going to write it as H2. So there's two H's, now two hydrogens. And the carbonate, which, oh my goodness, that's carbonic acid. Alert, alert, that is an unstable product. So that guy will break down. As soon as you see one of those two, carbonic acid or ammonium hydroxide, draw a little star beside it to remind yourself that is going to break down right away into a gas and water. The ammonium acetate is not so exciting. It's just, or sodium acetate, sorry, it's just sodium bonded to acetate, which is the other ion that swapped over here, the other anion. But watch out for that carbonic acid. Right away, that will break down into carbon dioxide and water. So our full reaction here, our full double displacement will actually be acetic acid, the vinegar, plus sodium bicarbonate, the baking soda, makes carbonic acid, but we're going to write that carbonic acid as water and carbon dioxide gas. So that's the key gas that we're forming here. And then we have our sodium acetate at the end, which is aqueous in solution. So it's that carbon dioxide gas that makes this experiment so exciting, and that's actually what makes this double displacement reaction possible. Otherwise, carbonic acid is actually aqueous and sodium acetate is aqueous. So you would think this would not go forwards at all because it doesn't form a precipitate. But because that carbonic acid right away breaks down into water and a gas, it actually does happen in this reaction. Let's do another example. Let's say you have ammonium chloride and sodium hydroxide. So ammonium chloride, sodium hydroxide, you're going to keep the cations in the same place, the ammonium and the sodium. And you're going to swap the anions, so swap the chloride and the hydroxide. So we'll get ammonium hydroxide and sodium chloride. Here it is in its chemical equation form, ammonium chloride, sodium hydroxide. Swap the chlorine with the hydroxide and keep the ammonium and the sodium in place. We'll get ammonium hydroxide and sodium chloride. As soon as you see that ammonium hydroxide, put a star beside it. That is one of your two unstable products. Ammonium hydroxide will immediately break down into water and ammonia gas. So watch out for that ammonium hydroxide. It'll split into water and ammonia gas. It would be aqueous otherwise. Ammonium hydroxide is aqueous, sodium chloride is aqueous. This reaction wouldn't happen if I was just looking for a precipitate, but in this case it's not going to form a precipitate, instead it'll form an ammonia gas. So this is what it looks like when I break that ammonium hydroxide down. I've got my NH4Cl, ammonium chloride, as a reactant. I have sodium hydroxide as a reactant, and I have ammonia gas as a product, and water as a product. And then of course I still have my sodium chloride in aqueous form as another product. All right, last example of a double displacement forming a gas is another kind of fun one. You can soak an egg in vinegar, and if you've ever wondered, well, what is an egg even made of? Its outer shell is actually mostly limestone. There's a few other things in there too, but the vast majority of an eggshell is made of limestone. And if you remember, the formula for limestone is calcium carbonate. So vinegar's acetic acid, limestone or eggshell is mostly made of calcium carbonate. And that calcium carbonate will react with the acetic acid to form carbonic acid, one of those unstable products, which will immediately break down into water and carbon dioxide gas. And you'll actually see it in little bubbles coming off of your eggshell. So if you put an egg in vinegar, you should slowly see little bubbles. This one's a lot slower than your baking soda and vinegar experiment. So it's not nearly as exciting, but it's still kind of cool because it sort of slowly disintegrates that eggshell by turning it into carbon dioxide and gas and water from that carbonic acid. So let's show it with our chemical formulas. Acetic acid is an H bonded to an acetate ion. Calcium carbonate, which is what eggshells are made of mostly, is a calcium bonded to a carbonate. The acetate and the carbonate are going to swap spots. So we'll get the carbonate bonded to the hydrogen, and carbonate has a -2 charge, so we're going to need 2 hydrogens there. And the acetate will bond to the calcium, and acetate has a -1 charge, calcium has a +2 charge, so we're going to need 2 acetates for every 1 calcium. This is not balanced, this is just a skeleton equation here. That carbonic acid is going to then break down right away into carbon dioxide gas and water. So here we go. Immediately H2CO3 breaks down into H2O, water, and carbon dioxide gas. So our full reaction will be acetic acid plus calcium carbonate makes water and carbon dioxide gas, and it's because it makes that gas that this reaction goes forward, plus also your calcium acetate. What we haven't done yet is balance it, so we can do that. Throw a 2, I don't have a ton of space here, but put a 2 in front of your acetic acid over here. Sorry, it should be right in front, it shouldn't be up high. That balances out my acetate ion here. It gives me 2 hydrogens, and there already is 2 hydrogens here, so that's great. I've got 1 carbon here, 1 carbon there. The other ones are part of the acetate ion, so they're already accounted for. In terms of oxygens, I have 3 here. These ones are part of the acetates already accounted for. And on this side I have 1, 2, 3 oxygens. So we're all balanced now for all of our elements there. And that is double displacement forming a gas.